Okay, so this question involves working with 3D shapes. It's got some lengths and angles, and it looks like it's got some right angle triangles that we can find within it. So it's telling us that it's going to be a Pythagoras stroke trigonometry question in a 3D shape. So we're going to have to break the 3D shape back into right angle triangles. So the question says that it wants to work with the line DE. So the best thing to do is to draw on that line. And it says it's making an angle with the plane ABCD, so we've got to remember the plane is just like a rectangle in space, and the plane ABCD is the bottom one of this shape. So it's making an angle, so we can join up to B, and therefore we've got this nice triangle, which is again another right angle triangle, and that's the angle theta we're trying to find. So my advice is sketch out the triangle that involves the angle you need to find, label it up appropriately using the letters of the question, and see what you know. Well, we know we need to find that, but unfortunately the way the question is being given to us at the moment, we don't know the length of that side and we don't know the length of that side. We do know it's a right angle triangle, so it's kind of screaming out at us because we want an angle. We're going to try and find two side lengths to work out the angle using trigonometry. So that means we've got to break this picture up into other right angle triangles. Well, we need this length dB, because that's going to help us find our theta, the question that we're being asked to work with. And we can see at the bottom here there's another right angle triangle. So if we sketch that one out, again, doesn't matter about being accurate here, we just sketch out roughly. So we've got a right angle triangle that goes from D to B, so D to B, back to A, and then across back to D. This time we do have some numbers. We know that the lengths are 60 centimeters and 60 centimeters. So that means I can work out the length of dB now, because we've got a right angle triangle with two lengths given. Third length can be found using Pythagoras. So we recognise Pythagoras' theorem says the short side lengths squared and added together must equal the long side squared. So again, we should really have that picture in our mind, that the two short sides and the long side, so the hypotenuse being the long side. So 60 squared plus 60 squared equals c squared. So c squared equals 7,200, so c equals the square root of 7,200. Now, as this is not the actual question answer needed, you leave it as the square root of 7,200. You don't need to put in your calculator and turn it into a decimal. This is an exact answer. We know it's the length of dB, so that's the square root of 7,200 now. So we can now add it on to the picture that we're going to use to work out our actual theta. So we know that's the square root of 7,200. We need to find the length of EB, so we go back to the original picture. EB is here, and we can see if we look on the side of this prism that we've got another triangle that's right angled with an angle and a length, so we could use trigonometry now to work out the length of BE. So if we sketch that triangle sideways, flat on, so we can see the information more clearly. So we've got 60, 30 degrees, and that's E, B and A, and we want to know that length there. Trigonometry, so car toa, and again we should remember that the labelling goes opposite the theta that we're wanting to find or use or given. So O, adjacent, and the hypotenuse being the longest side. So in this particular question then we ask ourselves, what do we know? Well, we know that the adjacent length is 60, we know theta is 30 degrees, and we want to know what's called the opposite length of the right angle triangle O. So when we go through here, we're going to be ticking O, we're going to be ticking A, O and A. This is the function we've ticked twice, so this is the function that we can use because we know enough information to find the missing bit. So we can write out what the ratio is. So the tangent of the angle is the opposite length divided by the adjacent length. We want to know the angle. No, we don't. We know the angle. We want to know the O. So we make O the subject. So we move A across. So A times tan theta is O. So A we know is 60. Theta we know is 30. So we work that out on our calculator. Again, making sure our calculator is in degrees mode. So we're doing 60 times the tangent of 30 degrees, so 34.641. 34.641. Keep a reasonable length to this number because it's not the final answer. but we do now know that that is the length of BE. So 34.641. So we go back to our original triangle now, the one that we're using to find the actual question answer, and now we can add on that this is now 34.641. So we've now got a right angle triangle with two lengths given, and we need to find the angle theta. So that is now enough information, because when we go through the SOHCAHTOA, because we know we're going to use trigonometry now to work out an angle in a right angle triangle. There's the right angle, so that's the hypotenuse. There's the angle we're dealing with, so that's the opposite side. And this is next to the angle that we want to find, so that's the adjacent side. So we ask ourselves the usual question, what do we know? Well, we know O and A, so we can go through ticking O and A. Once we've ticked one of these functions twice, then we know we can use that function to work out the missing values. So write out the function, so the tangent of the angle is equal to the ratio of the opposite length divided by the adjacent length. We want the theta, that's the missing value, that's what the question wanted at the beginning. So we rearrange this to make theta the subject, so that means we've got to do the inverse of the tangent function. So the inverse of the tangent function is known as tan to the minus 1. So now we can put our values in. So we know the O length was 34.641, and we know the other length was the square root of 7,200. So I left in the value of 34 point, so we got a fairly accurate answer there. And if I store that in A, right, so I want the second function, tan to the minus 1, brackets. I'm going to recall the A value, so that's 34.641. We're going to divide by the square root of 7,200. We're going to close the bracket, we're going to press equals, and we get an answer of 22.2 degrees. So theta is 22.2 degrees. So quite a lot of work, but these kind of questions are worth 5-6 marks, so they're expected to spend quite a bit of time on it. Again, let's look at the way it worked. 3D shape, it's asking us to work with finding an angle, and when we drew the lines on, we could see that the angle became part of a right angle triangle. So we sketched out the right angle triangle. Unfortunately, we didn't know enough information at the start to be able to go straight to the answer. So we had to find other right angle triangles that allowed us to get the missing lengths needed for finding the actual the angle for the answer. And through doing that, we worked out that we could use SOHCAHTOA. We knew two lengths in the end, go through the process, get the answer. Not too bad with a bit of practice, guys.